In this video, we're going to walk through how to find a minimum sample size for estimating the population proportion. It's really similar to the previous video about finding a minimum sample size for estimating a population mean. So the idea, again, is we want to control how wide our confidence interval is. We're going to choose the margin of error. And we also want to control how confident we are in that confidence interval. We're going to choose our confidence level. And based on those two choices, we're going to plug it into a formula and get what our sample size needs to be in order to have those two values the way we want them. So I'm going to walk through example 4 here. We're running a political campaign in which to estimate with 95% confidence the population proportion of registered voters who are going to vote for your candidate. Your estimate must be accurate within 3% of the population proportion. So the first part, we're going to find the minimum sample size needed with no preliminary estimate. Alright, so we've chosen to have a margin of error of 3%, 0.03, and we've chosen a confidence level of 95%, which means our alpha is 5%, which means there is 2.5% in each tail. So to find the critical z-value associated with 5% total, you want just 2.5% in each tail. So that's going to be our formula, and if I put an equal sign in front of it, Excel will tell me the critical value associated with 2.5% in each tail. Now the last bit I need in the formula is either the preliminary estimate for p hat, but since we don't have one, we use, because for example 1 down here, we're going with no preliminary estimate. We use 0.5 for each p hat and q hat. Alright, so with all that information, just plug in what we got here. So it's going to be equal to B1, our p hat, times B2, our q hat, times, now parentheses, we want our critical value associated with the 95% level of confidence, which was B5. We want that divided by our margin of error, which was B7. And that is squared. So close the parentheses and squared. And I need to make my column a little wider. Okay. So we need our sample size to be at least 1,068. Alright, so always round up to the next whole number. You can't sample 0.072 of a person. You have to sample the whole number of people. So the answer would be 1,068. And now in example 2, we're going to use a preliminary estimate of 0.31. So to kind of, before we do that, talk about, I guarantee our sample size is going to be smaller than this. When you have no preliminary estimate, we use 0.5 for both p hat and q hat, and that gives us the largest value back possible, the largest sample back possible. We're kind of paying a price for not knowing what p hat would be. Okay, so this part of the equation stays the same. The critical value divided by the margin of error squared. That's not going to change when I run this example 2. But these values are changing. And what I'm saying is any decimals you have are going to give you a smaller result than 0.5 times 0.5 here. And it talks a little bit about that in this inset box as well. Basically, without an estimate for p hat, you must pay the penalty of using a larger sample. So let's put in our new estimate here. It was 0.31. So 0.31. And then q hat is going to be 1 minus that. Oh, I typed that in wrong. 1 minus 0.31. So 0.69. 31% yes are voting yes, 69% are not voting for our candidate. So this critical value here, Not sure why that changed. I want the same number of decimals I had before. But anyway, like I was saying, when we update this with our estimate for p hat, because I had used cell reference, our sample size here automatically updated with the correct formula. But now we get a sample size of just 913. So having that preliminary estimate dropped us from having 1,068 to 913. And comparing the answers, you will see that the book has a slightly different answer. And that is because I'm using cell reference here. So Excel was doing an exact critical value that has a lot more accuracy here. So 913 actually is a better answer than the book has, but if you round here to 1.96 like the book had, you get the exact answer the book had, which then rounds up to 914. Another thing I do want to mention that you may have wondered about, I had this as the negative, and I didn't change it to a positive before I put it in the formula. I just cell referenced it as the negative. Technically, you probably should use the positive in the formula, but it's not going to matter because we're squaring the result. So when I'm using the negative, I get this 1.96 divided by 0.03. It comes out negative because I have a negative. But when you square it, you get the same exact positive result as if you used positive 1.96.